Today is the last lesson for Chapter 11. So again, tomorrow you have the class period to work on what we're doing today. Friday we start to review for the test. So today we are talking about the standard normal distribution. So we're applying standard normal distribution and z-values. So I actually have an example to start out so you can see why we need the standard normal distribution and then what it is as well. So we have, this is tying into what we did yesterday, building off of it. The number of videos uploaded daily to a video sharing site is normally distributed with a mean of 181,099 videos and a standard deviation of 35,644 videos. And it says find the probability below. So when you see something written like this is really asking you to find the probability that the number of videos uploaded daily is in between 180 and 200,000. So the way that's written, probability, X is between 180 and 200,000. Number of videos uploaded daily is between 180 and 200,000. So I'm going to set up my x-axis for my normal distribution. I have the mean is 181,099. And then just as we did yesterday, I can fill this in by going up 1, 2, 3 standard deviations and then down 1, 2, 3 standard deviations. So if I add one standard deviation is 216,743. 2 standard deviations above the mean is 252,387. 3 standard deviations above the mean is 288,031. And then if I go below the mean, 1 standard deviation below is 145,455. 2 standard deviations below is 109,811. 3 standard deviations below is 74,167. Those are all possible numbers of videos uploaded daily to this video sharing site. Okay, so think back to what we did yesterday with the empirical rule. Again, within 1 standard deviation is 68%, within 2 standard deviations is 95%, within 3 is 99.7%. And then we should be able to manipulate those 3% to get any other probability that we need. All of the problems that you had yesterday, the x values you were asked to find the probability of always appeared on your normal distribution on your x-axis. So those values were always exactly 1, 2, or 3 standard deviations either above or below the mean. If you look at the values we don't have 180,000 or 200,000 listed here. So if I were to approximate where these values would be, 180,000 would be just below the mean. I'm kind of just marking where that value would be. 200,000 would be roughly in between that mean and first standard deviation. So it's this area or probability that I'm trying to find, but I'm not able to use the empirical rule we used yesterday because those values are not exactly 1, 2, or 3 standard deviations away. So the empirical rule only works when your values are exactly 1, 2, or 3 whole standard deviations away from the mean. I can still find this area and still approximate that probability, but I have to use what are called z-values, and that process is called standardizing the data. So that's what's explained here. This is the one example we're focusing on today, so every time we go through an example, we're coming back to this same example. So as I said, the empirical rule is only useful if you're evaluating specific values, such as the mean plus 1 standard deviation, or again, like I said, a whole number of standard deviations away from the mean. Once you standardize a data set, any data value can be evaluated. So data are standardized by converting them to z-values. These are also known as z-scores. So if you hear a z-value or something asks you to find a z-score, they're talking about the same thing. The z-value, this is very important for you to understand what the z-value actually represents. The z-value represents the number of standard deviations a given value is from the mean. Okay, so what I want you to understand here, even if we looked back up at what we just drew up here, this x value of 216,743, if I were to calculate the z-value for that x value, that z-value would be 1 because it is 1 standard deviation above the mean. Okay, so the z-value is going to tell you exactly how many standard deviations a value is either above or below the mean. And so you could have z-values of 1, 2, 3, -1, -2, -3. However, because these x values are not an exact number of standard deviations away from the mean, these z-values will be decimals. They'll be in between. So this z-value should be somewhere in between 0 and -1 because it is below the mean. This z-value will be somewhere between 0 and +1 because it's above the mean, but it's not quite a whole standard deviation away. So make sure you understand when you're finding a z-value what it actually represents. And then z-values are therefore used to determine the position of any data value in a set of data. So this is how you calculate a z-value. The z-value for a data value x in a set of normally distributed data is given by this formula. So the z-value is equal to the x value minus mu, which is the mean. So the x value minus the mean, all divided by sigma, which sigma again is your standard deviation. So maybe on your notes, if you need to, label what the mu and the sigma represent if you think you're going to forget, but it's the x value minus the mean, all divided by the standard deviation. So this is still continuing from example 1. So in order to find this probability, this area, I would need to find the corresponding z-values or z-scores for these two x values. So I have that listed as example 1 continued here. I have find the corresponding z-values for the x value 180,000 and the x value 200,000 from example 1. And then we're going to describe based on their z-values what that position of that x value is in the distribution. So I'm going to work with the x value 180,000 first. And the formula to find that z-value is right here. So the z-value is going to equal my x value, which is 180,000, minus the mean in example 1 was 181,099, all divided by the standard deviation in example 1 is 35,644. Okay, now when you're calculating this, this you could calculate on any calculator. Just make sure when you type this into a calculator that once you subtract the values in the numerator, that you hit enter before you divide by the 35,644. And then I'm going to tell you to round your z-values to at least 2 decimal places. So I would say this z-value is -0.03. Okay, so that is the corresponding z-value for the x value 180,000. Now, what this means, because it does say indicate the position of each x value in the distribution, so what this z-value means is the x value 180,000 is 0.03 standard deviations. And then because it's negative, that means it's below the mean. So the x value 180,000 is 0.03 standard deviations below the mean. Okay, that is what that z value represents. Okay, it's the distance with in standard deviations, the number of standard deviations or partial standard deviations a value is either above or below the mean. So if your z value is positive, that x value is above the mean. Okay, any questions on that x value? We have to do that for the second one as well. Yes, if you did 0.03 sigma, that's fine too. Yes. Okay, so we'll do the same thing for the x value 200,000. Now, your mean and your standard deviation are the same. The only thing changing in this calculation is your x value. So I would take 200,000 minus 181,099, all divided by 35,644. And so that z value rounded to 2 decimal places is about 0.53 positive. So the position of that x value, I could say x equals 200,000 is 0.53. And this is what Carter just asked. If you don't want to write out standard deviations, if you want to put 0.053 and then the sigma symbol after that, that means 0.53 of a standard deviation. So you can write that as long as you understand what that means and that makes sense. So it's 0.53 sigma, and then since it's positive, this would be above the mean. Okay, so make sure, like I said, you understand what those z values represent. So now, and that part, none of this so far, we actually needed a graphing calculator for. We're going to get to that quickly here. So then what this is showing is it says any combination of mean and standard deviation is possible for a normally distributed set of data. As a result, there's infinitely many normal probability distributions, and this would make comparing two individual distributions difficult. However, any normal distribution can be standardized. So any x value in any normal distribution you can find a z value for or a z-score for. So the standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So I have this written down here again. You don't really need to pay attention to these percents. This is a normal distribution, so the 68, 95, 99.7 would still apply. But I do want to show you these values along the x-axis are always -3 through +3. So the reason the mean is 0 is because the mean is 0 standard deviations away from itself. So remember, these are all z values here. So what this is representing, if z is +1, that means you're one standard deviation above the mean, 2 standard deviations above the mean. So these are all z values. So for a standard normal distribution, these would always be the values here. Otherwise, total area under that curve is still 1 or 100%. Almost all of the area is between z equals -3 and +3. That's 3 standard deviations on either side of the mean, so that's 99.7% of your data from what we talked about yesterday. Symmetric distribution, mean is 0, standard deviation is 1. Okay, so again, we're kind of building to actually find that probability we were looking for up here. So if you flip this over, we'll get to what we need the graphing calculators for. What this is explaining is basically how using those z-values allows you to find any area, not just areas that depend on the 68, 95, or 99.7. So for any normally distributed set of data, if you find the corresponding z-values, you are able to calculate any probability, is what's being explained up here. So we're back to our original example. You don't have to fill this in again unless you want to. We're back to our original example. Back to this original probability we were looking for, and then I also have an additional one. And then in that second part of example 1, we had calculated what the corresponding z-values were for these x values. So 180,000, again, that z-value, I'm just going to write on this side of my paper, was negative 0.03. This z-value was 0.53. Okay, so in this type of problem, if you fill out a normal distribution, you fill out your values using your mean and standard deviation. If you see that your values do not appear on that x-axis, calculate the corresponding z-values, and then you'll use the graphing calculator to calculate the probability. So that's kind of the process that we're building on. So it says below, I have what you would type into your calculator to find the area between two z-values. So here you want to make sure you have your graphing calculator out and that it does turn on. Make sure it works. You don't.
I don't think so,
Not that
but I'm
I
not
found
sure.
yesterday, no, because I don't have a 7th-hour class. So
All right.
not that I saw, but I'll keep an eye out. It would still be over there if there was one in here. Do you have a question, Theo? Oh. Okay, so here's what you do. Once you determine that you need to find the z-values, you always need a lower z-value and an upper z-value. So in this case, because we did have two different x values that our probability was in between, obviously this lower z-value would be our lower, the 0.53 would be our upper. So I'm going to talk more about that in example B because there's only one x value used in that probability. But it says a method for calculating the area between two z-values is, and this is what gets typed into your calculator. This is what the command in the calculator will look like. So showing you where these keys are. So you're going to hit the second key first, and then the distribution, D-I-S-T-R, that is above. If you locate the VARS key, V-A-R-S, it's right next to clear. You'll notice D-I-S-T-R right above that, either in blue or that orange, depending on what calculator you have. So you have to hit second and then the VARS key, and you should get this screen. And if you want to make a note, the DISTR is above the VARS, just so you know that for tomorrow. And then you want the option that is normal, CDF, and that's option 2. So you would either arrow down to 2 and click enter, or if you just click the number 2, you could do that as well, hit enter. Now this is where if you have a yellow graphing calculator or yellow cover versus the black cover, your screen's going to look different. If you see this screen, the only things you enter in or change are the lower and the upper. The mean should be 0, the standard deviation should be 1, because we have a standard normal distribution. So these should never change, and don't change them. You would just enter in your lower z-value is negative 0.03. Make sure you're using the negative key and not the subtraction key. The negative key is below the 3. So negative 0.03. The upper z-value is 0.53. If you do not see the screen because you have a black covered calculator, then what you would type in, actually once you have this, I'm going to go to paste and click enter. All you should have to type in your calculator, maybe I'll grab one and just make sure this works here so you can see it. So all you should have to type in, so second VARS, option 2, you should just have to type in your lower z-value, so negative 0.03. Then you have to type in a comma. The comma key is above the 7. So type in a comma, then type in your upper z value, which was 0.53. And then just close the parentheses, and so that right parenthesis is above the 9. And then on either calculator you have, hit enter. Yes, and I'm getting the same thing on both. You should be getting 0.213910, so on. Anybody not getting that? Okay, so what this number represents, round this number to at least 3 decimal places. So this is your probability. So it's 0.21, if I round to the 3rd decimal place, that would become a 4. So it's 0.214, which represents 21.4%. And I would accept the decimal or the actual percentage, however you decide to write it. Okay, so that means there is a 21.4% chance that the number of videos uploaded daily would be between these two values. Okay, or this shaded portion that I drew at the very beginning, that is about 21.4%. Okay, so your calculator is finding that for you. Questions on that? Okay, so then quickly here for part B, to see how this is a little bit different. So again, I know I didn't rewrite the values here, but you can see I want to find the probability that X, or that number of videos uploaded daily, is higher than 250,000. So on my graph, I'm just flipping back to the front. For this one, if I locate approximately where 250 would be, because again, it's not one of my values, so it'd be about right here. And I want to know values that are greater than that, so I'm finding this area or probability for question B. Question, Adler? Oh, you just, once you type them in, you click paste, hit enter, and hit enter again, and it should give you the value. Did you use the negative symbol and not the subtraction symbol? Okay, after I show this one, I'll come back and see what's going on with those two. Okay, so for part B, try the one for part B, guys, and see if that one works, and then I'll come back by you. So for part B, this is what we're finding. So since 250 is not exactly 1, 2, or 3 standard deviations away, I need to find this z value. So to find the z value, again, the formula is on the front of your sheet. It's your x value, which is 250,000, minus your mean of 181,099, all divided by your standard deviation of 35,644. Just to save us some time here, you can calculate this, but this comes out to be approximately 1.93. So that is the z value. Now, because I want to find, remember I said you always need a lower and an upper. Because I want to find values that are greater than this, this is my lower z value. I do not have another x value, though, to find a corresponding z value to get an upper z value. So what I have stated down below is that the majority of your data are within 4 standard deviations of your mean. So remember, within 3 standard deviations, that's 99.7%. So if you go within 4 standard deviations, that's pretty darn close to 100% of your data. So if you need either a lower or an upper z value, a min or a max z value, use -4 if you need a minimum. Use +4 if you need a maximum. So if this is my lower and I need an upper z value, I'm going to use +4 for my upper z value. If I wanted values less than 250, then the 1.93 would be my upper, and I would use -4 for my lower. So you have to look at what you're trying to find if you should use positive or -4. That's only if you only have one x value to go off of. So then I would use these z values, again, type it into my calculator the same way I did here. So you want to go to second vars for the distribution, DISTR, option 2 for normal CDF, and here you're either typing in the lower and the upper, or you're typing the lower comma upper if you have the black cover. So my lower is 1.93, my upper is 4. Go to paste, hit enter. On this calculator you have to hit enter again. You should get 0.026 or 0.027 if you round to 3 decimal places. Okay, so this probability would be 0.027, which is 2.7%. So there's a 2.7% chance the number of videos uploaded daily would be higher than 250,000. Okay, so these are really just about understanding what you need to find. First, fill out your normal distribution, determine if you need z values, and if you do, you have to use the graphing calculator to find that probability. Guys in the back, did yours work for this one? Okay, did you figure out with the first one why it didn't work? Okay, you got it to work? We're good? Okay. Okay,